Now, last time we had our first class on matrices, so we're going to continue with matrices now. Right, so if we look at the next topic in matrices, so just actually before I start that, I want to show you a special multiplication example, okay? Suppose I was to take this matrix here and multiply it by this matrix here. It'll be the same. Let's look at the reason why. So if you take these two and multiply it by these two, you'll get A, because it'll be 1 times A plus 0 times C. And then if you take this one and multiply it by this one, what will you get? B. Yeah, it'll be 1 times B plus 0 times D, so you get B. And then if I take this one and multiply it by this one, I'll get C. And then finally, if I take this one and multiply it by this one, I get D. Which you see actually is this matrix here. Okay, so this is actually a special matrix, a very special type of matrix, this one here. Does anybody know the name of this matrix?
Identity.
Very good, identity. And what letter do we call it? I. So we call this the identity matrix, matrix I. It's special because when I multiply it by matrix X, it will always make matrix X. Okay? So in effect, it doesn't really do anything. It keeps the matrix the same. In regular algebra, what is this like? What is it like doing? Yeah, it's like multiplying by 1, isn't it? Because you know 1 times x is x. Likewise here, I times x is x. Okay? So the identity matrix I does not do anything when multiplying matrix X. Okay, so that's the first idea, identity matrix. Now, if you think about regular algebra for the moment, what number must I multiply 2 by so that the answer is 1? What number should I put here?
2.
Half or 0.5? Yes? Wrong way around, yeah. 0.5. So, remember the 1 here is a bit like what? The identity. This is a bit like x. This is a special number that when you multiply it by the x makes 1. So what name can we give to this? Does anyone know? No, it's a word. Inverse. Do you know this word? Inverse. This is called the inverse because when multiplying by the x, it makes 1. So for every number except 0, it has an inverse in normal math. So for example, 10, what's the inverse of 10? 1 over 10, you know. So the same thing can happen for matrices. Let's have a look at an example here. If I call this matrix here X, this is matrix X, and if I multiply it by this matrix here, let's see what we get. So 4 times 3 is 12. 12 minus 11 is 1. 4 times minus 1 is minus 4. And then 1 times 4 is 4. Add them together, 0. And then do the same for the other two and you get this, which is called identity matrix. So what's the name I can give to this one? It's called the inverse. Now what we're going to look at is how did I find this inverse here. Sorry about that. Inverse. How did I find it? And the way we write inverse is x with a little minus 1 up the top. That means inverse. Okay? Finding the inverse is useful because it means when you multiply it, it cancels it to make this I here. And we'll look at a little bit more about that in the next class. But right now we're going to be worried about how to find the inverse here. Okay. Right. Do you need a minute to write that down? Yeah? Okay. Okay. Do you have it? Yep. Okay. Let's try and figure out a formula to find the inverse. So, we have matrix A, B, C, and D. And I want to find the inverse here. And I don't know what it is. So maybe I'll just call it something like W, X, Y, and Z. And I'm trying to figure out what these are. But I know what should happen when I multiply X with its inverse. What should I get? I should get 1, 0, 0, 1. Okay, let's multiply the left here and see what we get. So I get AW plus BY. And then here, AX plus BZ. CW plus DY, and then finally CX plus sorry, which one? AX, sorry, I wrote W plus BZ, so that should have been X. Okay, and then this last one here, CX plus DZ, so what am I doing there? DZ. Okay, and that should equal 1 here. I should get 0 there, should get 0 there, and I should get a 1 there. Okay. So I need AW plus BY to equal 1. I need AX plus BZ to equal 0. I need CW plus DY to equal 0, and I need CX plus DZ to equal 1. And remember, I'm looking for W, X, Y, and Z. Okay, so let me just highlight what I'm looking for here. Oops. Okay, W, Y, X, Z, W, Y, X, and Z. Okay. How many equations do I have here? 4. And how many unknowns do I have?
8.
Well, not actually 8, because some of them are repeated. So I have 4 equations and 4 unknowns. So I could solve it. However, in the last class, you only learned how to solve 2 equations with 2 unknowns. Okay? So this can be what we call in maths an exercise you can do at home yourself if you want to see it done yourself. But I won't do it here for you. I'll just jump straight to the solution, okay? So the solution turned out to be W, X, Y, and Z. So W equals D over AD minus BC, and then X minus B over AD minus BC, and then Y minus C over AD minus BC, and then finally Z was A over AD minus BC. And when you look at all of these, you notice that there's something in common with all of them. What's that? The denominator is the same. It's AD minus BC. So because of this, it'd be convenient just to call that one thing. So in maths, this is our first new word for today. We have something called the determinant. Yes. Determinant of x, which we can just write as det x. Or sometimes people just write it as well, no, actually, I won't show you that one just yet. So DETX. So that actually means, here's your first formula, AD minus BC. That's called the determinant of it. So putting all of this together, we have our answer. I'll scroll back up if you need to. If matrix X equals A, B, C, D, then we say the inverse of X is this formula. It's 1 over determinant of X. What's determinant of X? AD minus BC. And then what you do is you swap these basically. So you put a D here and an A here, and then you minus those.
I have a question.
Yeah.
Yeah, okay, yeah, that's what I was.
It's okay?
Yeah.
So if you need, do you need to write this down here? I'll give you a minute, and then we can go down to the formula. So homework for those who are interested in how to get from there to there. Only for those who are interested. Okay. So this is our formula for the inverse. So let's have a look at an example. For example, I have the matrix 1, 2, 3, 1, and I want to calculate the inverse of it. So first things first, I calculate the determinant, which is AD. So what's AD here? 1 minus BC. So 1 minus 6, which is minus 5. Yes? So this will be 1 over minus 5. Then what do? I said I swap these numbers, but they're actually the same, so it's still 1, 1. And then what do I do with these two? Minus them, so I get minus 2, minus 3. Now, I don't really like this minus being stuck on the outside, so I can multiply the minus in, but I'll leave the 1 over 5 on the outside. But you can multiply it in if you want to. So the answer will be 1 over 5 minus 1, 2, 3, minus 1. I'll do another example as well. Yeah.
Why do you need that 1 over 5?
Why the 1 over 5 part, is it? The formula actually has in the front of it 1 over determinant. And the reason for that is because it needs to be in the denominator.
So if we multiply the original matrix through the...
Yeah, if you multiply this original one here with this answer here, you will make 1, 0, 0, 1.
With the 1. Okay.
Yes, with the 1 over 5. So what would happen is, for example, if you multiply this with this, you can leave this number until the end, and you would get something that looks like this. And then when you multiply it in, 1 over 5 times 5, 1, 0, 0, 1. Okay? If you didn't know that, when matrices get multiplied by this, what do we call a single number? What's the name of a single number? I gave it to you yesterday. Yeah.
Scalar.
Scalar. You can do the scalar multiplication at the beginning or at the end. Yes?
Could you go 1?
Yep. Do you want to go up to the previous page?
Yeah.
Okay.
More.
More?
Yeah.
Here?
More.
Oh, dude.
Sorry.
No, you'll have to get it later from someone. You've pushed it too far now. I'd be willing to go to here.
Because you said that x inverse equals with the a, b, c, d. You said that
This here is like the x, and I'm trying to find a formula for the inverse here. So I don't know what letters to put inside of it. It's like I know A, B, C, D, and I want to find what ones to put in here. I sense confusion. I'm going to do some more examples, okay? Here. I'll do another example here. So if I have the matrix 1, 2, 2, 4, and I want to find its inverse, first determinant, 1 times 4, oh actually this is a bad example, let me change this to 3. Okay, 3 times 4, 12, 12 minus 4, 8. So it's 1 over 8 times, swap those, and then minus the others. And that's the inverse. That's the answer. And if you multiply this matrix with this matrix, you will get 1, 0, 0, 1. Okay?
This is actually more clear. You said no.
Good. I felt I needed some more examples. Another example. 4, 3, I think I've done something like this earlier. Inverse of this. So 4 times 3, 12. Minus 11 is 1. And 1 over 1 is just 1. So I won't even bother to write the 1 down. 3, 4, minus 11, minus 1. And that's it. I think that was the example I gave near the start, wasn't it? 4, 1, 11, 3. Well, similar to it. It's very nice when the determinant is 1 because then you don't have some messy fraction in the front. Yeah? Your question is how to go from here to here. Is it? Or? Okay, I'll do some more examples. Write these. There's 3 examples there for you. Well, 2 examples that you can see here. But look, I'll just do some more examples. Okay. So for example, I have x equals 4, 1, 2, 0. And I want to know what is the inverse of it. So the process is as follows. You multiply these, what do you get? 0. And then you multiply these, what do you get? 2. So 1 over the determinant, that is going to be 0 minus 2. Yes, which is minus 2. Then, what do you do next? You swap these 2. And then what do you do with these 2?
Negative.
Negative. Change the sign. So you get minus 1 over 2, 0, minus 1, minus 2, and 4. And if you like, you can put this on the inside. So 0 times minus a half? 0. Minus 1 times minus a half? A half. Minus 2 times minus a half? 1. And 4 times minus a half? Minus 2. So this is x inverse, and then the original x, just to write it down, was a 4120. And if you multiply those matrices, I promise you, you will get 1001, which is the identity. Okay, yeah?
The second one, you always subtract the
Sorry, let me see. This line here? Here? Yeah, it's always subtract. It's always A times D minus B times C. Always, yeah. Okay. Now, question? Question? Dudes, question? Yeah, what's the question?
How can I get the determinant?
Yeah, the determinant. I haven't really said too much about that. I'm going to talk about that now, okay? So, there's one small problem with the determinant. It can't be what value?
0.
Why not?
I'm not sure.
It was your instinct, was it? Why can't it be 0?
Because then it would be 1 over 0.
Then it'll be 1 over 0. So it's very important to calculate the determinant to make sure it's not 0. So if I give you this matrix here, 4, 1, 2, 1, it's always good to check at the beginning what the determinant is. And the rule is 4 times 1, which is 4, minus 1 times 2, which is 2. So the determinant here is 2. Okay? And then if you were to look at this one, What would that be?
6
8,
plus
8,
Minus 8.
plus 0.
which is 0. This is a problem, because in your formula for the inverse, you have 1 over determinant, and it's a big problem to have 1 over 0. No problem here. This is good, this is bad.
And when we get to 0, what do you do with that?
There's nothing you can do. So we'll look at some questions now, but sometimes the question might say, does this matrix have an inverse? And if it is 0, then it has no inverse. And if it's not 0, then it does have an inverse. Let me write that down for you. So for example, if determinant of x equals 0, that means there's no inverse. Why is there no inverse? Because you're dividing by 0. Right? Okay. If the determinant of x is not 0, then that's good news. Then you do have an inverse. There is an inverse. And that's important to know, because in the exam, this is something that does come up. They'll ask you, does this matrix have an inverse? Or, what I'm going to do next is, what value of x will give this matrix an inverse or not. So, down here, example. I tell you here that this matrix has no inverse. So if this matrix has no inverse, what can you say about the determinant? The determinant must be 0. So what is the determinant of this? This would be, yeah, well, if we calculate, what would it be? 0 minus 4x. And I said it has no inverse, so what should this equal? 0. So therefore, what's x? 0. Now let's do the other example. Suppose I tell you it does have an inverse. So I tell you that this matrix does have an inverse. So what can we say about the determinant?
It's not 0.
It's not 0. And what is the determinant here? 3x minus 9 is not 0. So 3x is not 9. So x is not 3. Okay? So if I tell you this does have an inverse, at least you know that x is not 3. Of course, you haven't found x, you just know that it's not 3. Okay? Right. So this kind of gives us an important idea, important note. In fact, it works both ways. Okay? If I have a determinant that's not 0, then I have an inverse. Okay? But it also works backwards. If I know there is an inverse, then the determinant is not 0. So they go together. Determinant is not 0, it has an inverse. It has an inverse, determinant is not 0. They pair together. Okay. If the determinant is 0, then no inverse. And likewise, no inverse means
0.
determinant is 0. So these statements, you know, they go perfectly together. They're equivalent. They match up perfectly. Okay? Right. Now, just a bit of notation, just so you're aware. This means determinant, and so does this. Okay? If you write these straight lines, it means you want the determinant. Okay? So when you draw your matrix, please make sure it's nice and round, so it's clear that you mean it's just a matrix, and nice and straight for determinant. Okay?
Can I make it like this?
Yes, that's okay. For which? Determinant or not determinant?
No, not
Yes, that's okay. Yes. But I do prefer these brackets. Okay. Okay. Remember yesterday I told you that AB does not equal be A? Yeah? I said generally not, but there are some special exceptions, but generally this is not the case. They're different. And the special exception is what we're doing today. If I multiply x by x inverse, I should get what? I. And likewise, if I multiply x inverse by x, I should get I also. So in fact, this is a special exception to this rule. X times x inverse equals x inverse times x. Okay, special exception. Okay, so make note of this. So this is normally the case, but here is the special exception. Oops. Okay. I think this is a very good question because if you just practice a few of them, you should always get 100% right, okay? If you just be careful with your pluses and your minuses, there's no reason that you shouldn't get this fully right, okay? So it is a good question, okay? And just to practice, for now, I'd like you to do, this is page 13. A and B for each of them, okay? So 1AB, 2AB, 3AB, 4AB, and 5AB. If you can try those now, and then while you're doing that, I'll check on the homework.